Hi everyone, today we'll do Cambridge International A-Level Further Mathematics Syllabus Code 9231, and we'll do Paper 2 Further Pure 2 Variant 1 from the May-June 2025 series. I've already done question 1, now we'll do question 2 it's a pretty interesting calculus question involving definite integral and hyperbolic functions. Okay, so first they are given us an integral with arbitrary power n here, where n is greater or equal to 2, and we want to show or prove that the integral can be also written as this like sort of iterative form of integral. Okay, so uh, we have something multiplied by something in the integrand, so that gives a hint that we need to use the integration by parts. And I think integration by parts should be given in the formula sheet, right? Somewhere here. Has to be here. Is it not given? It should be given. Um, Anyway, I mean, if you, I think at further maths level, you should be expected to know how to prove also the uh the result of the what's it called, integration by parts, right? So you know that the product rule UV, if you differentiate the product, you get differentiate the first one, leave the second one, and then leave the first one, differentiate the second one. So if we integrate this on both sides, right, we get a uv equals to u prime v plus uv prime, and therefore we rearrange this to get our integration by parts formula. Okay, so even if you it's not given in the formula sheet, so you should be able to derive this on the spot also. So let's choose, I mean, obviously we want to choose u prime as the one that's easier to integrate. In this case, it's easier to integrate the hyperbolic sine function because we know, I think it's also given here. Yeah, if we, yeah, we have the sine, hyperbolic sine integrate just to become hyperbolic cosine. So or let's just do that first. So D stands for differentiate, I stands for integrate. So first I will differentiate the v, that means v will be 1 minus x power n, and u prime, that will be the hyperbolic sine function. And yeah, n is just a constant, so we just treat it as a constant. And if we want to differentiate this function, all right, v prime will have to bring down the power, and we remain this one, and we take away one from the power. Don't forget, we need to use the chain rule to multiply by the negative inside. Okay, then to integrate the hyperbolic sine, that's all we need is to just look up the table, right? Look up the table, and we just get hyperbolic cosine. So this is our integration by parts formula. Yeah, plus minus, and then use the uv, okay, uv, and then integrate the u prime, u v prime. So let's rewrite this. 1 minus x hyperbolic cosine, and remember the limits is what? The limits is from 0 to 1. Okay, the minus negative, so it's a positive, and 1 minus x and minus 1, and a hyperbolic cosine, and again the limits. So here the limits, if we plug in 0, sorry, if we plug in 1, it goes to 0 because the 1 minus 1 here equals to 0. Then if we plug in 0, cosine, hyperbolic cosine is just 1, and we plug in 0 here, that's just 1. So 1 multiplied 1 is just 1. Okay, and then we have an integral here, and again it's just a constant, so I'll bring it out of the integral, 0 to 1. Alright. Okay, this integral, again we need to do the integration by parts again. So again, I'll write my d and I'm gonna differentiate again this linear term, and I'm gonna integrate the hyperbolic cosine. So again, this is my v, this is my u prime, my v prime. Bring down the power and take away one from the power. don't forget to use the chain rule to multiply by the inside. And mu, again, just look up from the table. Hyperbolic cosine, integrate, you get back the hyperbolic sine function. Okay, so just that. So again, you have a negative, and then you multiply, and then you integrate the row. Okay, so again, I n is 1 plus whatever this is. Okay, don't forget the limits, 0 to 1, 0 to 1, integrate. Don't forget here also the n is still here, so the n leave it outside the integral. So that means n is also here, right? Okay. Alright, let's deal with these limits first. So here, substituting 1, we get 0 again. Substituting 0, we get substituting 0, yeah, we get 0. So this 0 here. Yeah, we substitute 0 means sine, hyperbolic sine of 0 is 0. So yeah, we get 0. And then here, we integrate. Okay, why we stop here, this integral, we can factorize, or we take this n minus 1 term outside of the integral sign, because that is a constant. And then we have this expression, which is, if you look closely, is the exact same as the one that's given to us, in, right? And the only difference is that we have a power of n minus 2 here. So this one actually we can rewrite as in to the minus 2. So we can do this, in to the minus 2. Okay, so is it the same? Why is there a negative in front of my 1 here? Did I miss something here? Okay, yeah, it should be negative, because when I substitute 1, there will be 0, and then minus substitute 0, there will be the hyperbolic cosine of 0 is 1, and then 1 power n is just 1, so it's a negative 1. Okay, so that's what I missed. Okay, so yeah, now we have shown this. And now we want to find the exact value of I2. Okay, so I2 means our n will be 2 here. So I2, then we substitute 2 in all the n values here. And in minus 2, that just gives us I0, right? And I0, let's just look at what our integral here. So this power 0 means this entire term becomes 1. Okay, anything power 0 just 1. And so we are left with, this reduces to 2. And we integrate from 0 to 1, just a hyperbolic sine function. And hyperbolic sine function, we know it integrates to cosine. So we have a hyperbolic cosine 0 to 1, and okay, so the hyperbolic cosine of 1, okay, hyperbolic cosine of 1, we need to, okay, they want the exact value, okay, so we need to use the identity then. I also believe this should be here, right? The hyperbolic cosine, is it here? Okay, so they expect you to remember it. So the hyperbolic cosine is this one minus the negative exponential divided by 2, say 1 0. So at so it's plus, right? Hyperbolic cosine is plus. So at 1, so it's E plus E inverse divided by 2. When it's 0, that is just 2 over 2. Alright, so we have here e plus reciprocal of e minus 3. So I think this is our exact value. Okay, so that will be question 2.